protocol, instant transfers on the Ethereum mainnet. Please welcome Lorenzo Feroleto and Nicolas Racchi. Round of applause, please. Woo!
Hi, everyone. So, I'm Nicolas, and this is Lorenzo, and we want to introduce you Bolt, which is the first proposer commitment protocol on Ethereum. So, let's first start with a quick overview of how Ethereum works today. So, if you want to buy an NFT or a token or anything else, you will notice that your transactions take quite a few seconds to actually settle and give you a confirmation. Bolt aims to change that with instant transfers. So right now, Ethereum has a single what's called leader consensus mechanism, which basically is a big word for something that something simple, that only one validator at a time is choosing the contents of a block. So in Ethereum, there are more than 1 million validators right now, but only one of them every 12 seconds gets to actually publish their block. This is what we call proposer monopoly power. The proposer is the term for the validator when they propose an actual block. And the monopoly is because they're the only party that actually makes any decision into whether they should include or exclude some transactions, or the order of which they actually include the transactions. I want to also stress that when you send a transaction, normally you don't send it directly to validators, but you send it either to a network, which is commonly called mempool, or to private parties such as block builders. Normally, when you interact with a wallet, you don't even notice this, but we need it for context on what we're going to explain later. In each commitment, which makes them credibly without trust. So you don't need to know the proposer that you're asking to. We also have a mechanism to trustlessly figure out if the proposer actually was fulfilling the commitments or not. So this is the very simple schematic of what we mean. As a user, you talk to the proposer, give them a tip, and receive a promise of inclusion or a promise of something back. And with Bolt, you can not only speak to the next proposer in line, so the one that's going to build a block in like 10 seconds or something like that, but also in the next 32 slots, so that's about a few minutes ahead. So you have something that we call a look-ahead window of a few minutes in the future. As I mentioned, Bolt is a proposer commitment protocol, meaning that you can ask the proposers whatever. It doesn't have to be a transaction inclusion or something in particular. And it allows users to communicate directly with proposers. Lorenzo?
So what can you build with Bolt? The biggest example is pre-confirmations. Pre-confirmations are a type of proposer commitment where, as we have seen before, the proposer is going to commit to include your transaction, and this commitment is backed by an economic value. If it doesn't behave well, if it misbehaves, it's going to get slashed, so it's going to lose some money. And why pre-confirmations? Because with pre-confirmations, you can actually send if ERC20s or NFTs or mint them, transfer them without instantly in, let's say, 200 milliseconds without waiting for like 6, 7, or 10 seconds like usual mainnet flow. And how this happens? As a user, this is completely abstracted away for you. You're going to just receive like a quicker feedback that your transaction has been executed successfully. but your wallet in the background, we're gonna send a request to the next proposer in line running Bolt, and it's gonna accept your commitment if you pay a reasonable tip, and it's gonna include your transaction. The idea, the vision here is to experience Ethereum like as fast as a rollup like Arbitrum, but leverage mainnet liquidity. So a question is, I've mentioned the ETH transfers or RC20's transfers, but can all transactions be pre-confirmed? The answer is quite delicate. It's a bit on the no side because in general we can only guarantee like inclusion and successful execution for a transaction that cannot be invalidated by other users. So for instance, in the context of ETH transfer, upon some basic checks, like you have enough balance, you have enough ETH on your wallet, you can just send your transaction, gets pre-confirmed, and it cannot fail. But that's not really like the case for swaps, because let's say the next proposer in line is in 3 blocks, and I'm gonna send him a swap, and it's gonna pre-confirm it, but what could happen is that price can change, and as such, my transaction could fail due to slippage tolerances on DEXs. But, so we have said that you could make deal with proposers, but why a proposer can make a deal with you where it's gonna say, okay, your swap is gonna execute successfully? Actually, that's a bit complex compared to ETH transfers, as we said, because suppose the next proposer, like the next blocks, is going to be proposed by a proposer running Bolt. Then, since it has monopoly powers over the contents of a block, it could place your transaction first, and then it cannot fail because there are no transactions before yours. And in theory, this works, but actually, the proposer might not be incentivized to do that. And why that's the case? Because in Ethereum blocks, usually the top transactions in a block are merely like SEX, DEX arbitrage that are really high value. So the proposer is incentivized to keep those on top of the block in order to profit more from its activity. And as such, it's hard to say as a user, I'm going to give you a tip to successfully execute my swap, because the proposer doesn't really know if it's enough, and we don't want Bolt proposers to be like super sophisticated in which software they run or which logic they operate. We want to keep the network decentralized as possible, and as such, we best think that it is offered to first offer pre-confirmation just for a subset of transaction, which is still really relevant because most of the time we are just like sending assets, which are transactions that cannot fail. But the question still remains, can we build like a DeFi protocol powered by pre-confirmation? In our opinion, like, the answer is yes, because pre-confirmation will enable like a fast DeFi UX and leverage Ethereum mainnet liquidity. So for example, existing protocols could be improved. Think of a lending protocol where like operation like lending and borrowing could be pre-confirmed because there are no contention, they're not going to fail. And also that's the case for depositing and borrowing in stable pools like USDC or USDT. And also we believe that with this new privity that's coming to live to mainnet in the next months, apps will be like incentivized to build with this new primitive in mind to offer like a better user experience to users. So there's going to be like competition incentives to do that. So back to Nico.
Thank you. So in Ethereum right now, there is a concept called PBS. And basically it means that proposers, validators, don't normally build all the transactions and decide the sequence of them by themselves, but they outsource this task to someone called a block builder. You might have heard of names like Beaver Build or Titan, but that doesn't matter. Basically, they are companies specialized in building the best block possible with the most value possible every 12 seconds and serve them to the proposers that just have to accept them. And with Bolt, we actually extend the API, so the interface that these block builders use, in such a way that proposers now can show to block builders, hey, I committed to a few transactions, to including them in my block when I'm scheduled to propose. And so builders will have to comply to those commitments. And this is really cool because it doesn't add any trust assumption, any trusted party checking if they're doing everything right. It's all based on proofs. I'm going to give you a very short overview of how it works. There are a few components, but basically the gist of it is that the validators will have to change their setup with a new component that we call Bolt Sidecar. As a sidecar is an extra software that validators will have to run alongside their beacon node and validator node. And we also modify with the red arrow a few APIs that make this happen.
So regarding trust assumptions, as mentioned, as Nico mentioned, we try to be as trusted as possible. So we are no new intermediaries are introduced. Both is completely trustless because proposers, in order to offer these commitments, need to post some collateral, stake some collateral, and in case they misbehave, this is gonna be slashed. And also, transaction inclusion is cryptographically proven, and we can leverage the native Ethereum data structures for that, in particular Merkle Patricia tree and their inclusion proofs. And lastly, if a proposer misbehaves, there is like a fully on-chain mechanism for fault attribution, like for rollups, for stage 1 rollups, which runs optimistically, so it greatly reduces costs because it doesn't need to be verified upon sending on transaction. At the end, we want still like the same UX and the same cost, almost the same cost for users. Let's give like a quick overview how it works under the hood. So in case a proposer misbehaves, as a user, you have a commitment that you can like post into a smart contract by opening a challenge. And the proposer has like a time window where it could dispute the challenge and eventually resolve it if the transaction was actually included. And the proof of inclusion consists of a Merkle Patricia tree of the transactions tree. So transactions in Ethereum, along with other like type of data, are grouped in this data structure called Merkle Patricia tree. They can give you some proofs of inclusion of certain data very succinctly. And the root, the hash tree root of root hash of this transactions tree is posted on Ethereum block headers. So if you go to Etherscan and check a block, if you see the field transactions root, that's what we're referring about. And if the proposer doesn't respond in time because it has misbehaved or provides an invalid proof, it's going to get slashed. Oops. But yeah, thanks for listening and tuning in. This is Bolt Protocol, and we are Chainbound, a research and development field working on Ethereum infrastructure. So there is like the Bolt Protocol.